think what I'm really interested in when I hear about this conversation is the hidden layer behind carbon markets and carbon credit. And for me, the hidden layer is the data, and not just any data, geospatial data.
I'll go first. There is something on emission and the industries.
Right.
Industries normally tend to pay the carbon tax. The industries releases the emissions into the atmosphere. You, as the farmer who has planted the trees, you are trying to ingest. That is your role as a GIS Data Analyst. You want to keep an inventory of all the farms in Kenya. Most of the methods for these estimations are fragmented.
Right.
So I always visualize that one as a gap. Should be a system for each ecosystem, be it the terrestrial, be it the water, the marine. You have quantified your carbon. So to stakeholders, you need to tell them, is this a carbon sink or not? Or what interventions do we need?
The money matters. In this Singapore economy, money really matters.
It might range between 80,000, that is per month, 80,000 to about 180.
GeoHabari podcast. So there's been a lot of talk around carbon markets, carbon credits, all these things surrounding the carbon conversation, right? And I think what I'm really interested in when I hear about this conversation is the hidden layer behind carbon markets and carbon credits, right? And for me, the hidden layer is the data, and not just any data, geospatial data. And so that makes this episode really exciting to get into, to just look at the critical questions that geospatial information systems allow us to answer. And very importantly, precisely, how does it allow us to answer questions around carbon credits, carbon markets, what questions does it look to address, and where do geotechies sit within the carbon markets conversation? So ladies and gentlemen, allow me to welcome this episode and the guest for this particular episode. I am your host, Yariwo Kitio, and welcome to the GeoHabari podcast. So before we start, I want to welcome, this is a very special episode because the episode, this season we're introducing a co-host. And so my co-host is on set and I'm really excited to have her on set. So drum rolls for that, yay. And then most importantly, we have a guest who has worked within the carbon credits component and at a very granular level, at community level. And for me, that's the hidden layer. What does impact look like, right? What data sets go into informing carbon markets or carbon credits? And then what data sets go into that? And that's what makes this conversation really important. So yes, if you're interested in how carbon markets work and where GIS sits within that conversation, then this is the episode for you. So ladies and gentlemen, welcome to this episode, and allow me to welcome my co-host, Joyce, and our really special guest, Samuel Ambuka, who works within the carbon credits conversation, but also carbon markets, that entirety. And that's what this episode is about. So yes, allow me to welcome our guest. Hi, Joyce and Sammy.
Hello.
Hello.
How are you guys?
We're good.
I'm good.
So maybe I didn't do you guys justice with the intro. So I'll have you guys introduce yourselves first in your own words, and then we'll jump into, having fun on set with this carbon ecosystem conversation. So I think we'll start with Joyce, who is our co-host for this season, and then we'll shift to Sammy, who is the brain for this conversation, quite literally. But yes, over to you, Joyce.
Thank you, Yariwo. Hi, guys. My name is Joyce Gathoni. I am a geomatics engineer by profession. I work very well under pressure, I think. Yeah. I'm also a fun person to be around. I think I was told to say a fun fact about myself. Maybe fun fact. I speak French.
I think the fact that you work under pressure is also a really fun, is a very big fun fact about yourself.
Yeah.
Yeah.
Because I'm a procrastinator so deadlines are my thing. Yeah.
Welcome on board, Joyce.
Thank you.
And then our brain. Can we call you our brain for this conversation?
Yes. I'll be glad to.
Sure. But Sabi, you could introduce yourself in your own words, and with a fun fact.
Okay, thank you, Yariwo. And my name is Ambuka Samuel Mbwanga. Initially a graduate of Geospatial Information Science from Jomo Kenyatta, but currently a practicing GIS Data Analyst. And then I was told to
A fun fact about
to
you.
say about a fun fact about myself.
Yeah.
So personally, I love watching animations.
Oh,
And
really?
with my most favorite show being The Simpsons.
Oh.
Yeah. Yeah, I like them a lot. And so they just remove that kind of boredom, and they give you that kind of break when you move in between episodes of work or something. Yeah.
Oh, nice to meet you, and thank you, Samuel, for coming to today's episode. We're excited for this.
Okay.
So before we start, I'm glad both of you said you did geomatics engineering and you're practicing analysts. And Joyce said she works really well under pressure. So I want us to start with playing a game. I have a deck of cards here.
Okay.
Does any of you know how to shuffle?
Shuffle, yeah, I know.
Oh, yeah. Okay.
Ladies first.
Give the
You,
guest.
you know what? You both can shuffle. As you're shuffling, so it's a deck of cards. We played this game on GIS Day, so it has myths around tech.
Okay.
So how the game works, they'll shuffle and then they'll put the cards here, and then every person will pick a random card and read it out loud, and then say whether that is a myth or not, and then describe it in very few words on whether you agree it's a myth or not. Yeah. So that's the nature of the game.
Okay.
So I think in this case, I just want to say that my views are mine and not a reflection of my lecturers in any way, in any whatsoever. But
Are
yeah,
they a reflection of the podcast?
no, they are not. They are my
Personal.
personal views. Okay, you guys can pick a card. Are we allowed to exchange? No, you have to redo. You can't read before all of us read.
Oh, I thought.
Sorry, I forgot to say that.
Okay.
Okay, pick now. So that we all think at the same wavelength. Or not wavelength, but at the same time. Sammy, it's
But
far.
it's different questions.
Yeah, but see, we can think at the same time. Where do you want to process before us?
No, wait. Help me understand the game. Once I read the
So now
the
we
card,
can read at the same time.
Yes.
And then, I don't know, I think who wants to go first?
Are we going to read it out
Yes,
loud?
you read it out loud, what your card says.
Okay.
And then say whether you agree or not.
Okay.
And there's no right answer, by the way. It's you defending what your thought is on that card. Okay, we
Okay.
can read.
At once.
Who wants to go first?
I'll go first.
Okay, what's your card?
Okay, my card is on data creation. Is the hardest part of a GIS project.
Data creation?
Data creation is the hardest part of a GIS project.
Do you is that true or false? Is it a myth or a?
That's a myth, according to my sentiments.
Okay, what's the hardest part in your?
To me, the hardest part is documentation of the whole process.
Oh, that's interesting. So documenting like the entire
The
process
flow,
of what you've done.
The logics, why you're arriving at. So if you say, for example, you're choosing a certain analytical process to analyze,
Yeah.
why are you choosing that? You have to document why you're choosing that.
Okay.
Which author used that kind of method to do an analysis? What were the shortcomings? You have to highlight why you zoomed into that particular method. So you have to document all that. So to me, documentation
hardest.
is the hardest thing.
Okay,
But
that's
troubleshooting around data creation and everything, it's not that hard.
Okay.
Yeah.
Okay.
Oh, interesting. Okay. So mine is saying the myth here is data cleaning is not work. Data cleaning is not work. Is it work? Hey, data cleaning is work.
It's a lot of
Data
work.
cleaning. In fact, data cleaning is majority of the work we end up doing.
Thank you.
Yeah, data cleaning is definitely work. Definitely work. So I would say, yes, this is a myth. Data cleaning is work
Okay.
that we need to bust.
My question is, my myth, NDVI is the only vegetation index anyone needs. Guys, come on. Come on. Do I need to say yes or no to that one? But I think NDVI is a very core.
It is.
A very core
Yeah.
index. So people tend to not think about all the... Even when you're saying indices, you say, for example, the NDVI.
Yeah. So for you...
Initially, also in my undergraduate, I used to talk a lot about NDVI. Before I moved to very many indices later on.
Yeah. Oh, that's interesting. So yeah, those are we've busted the myths and explained. So we'll just jump into the episode. Right. So on why we're here today, carbon credits, carbon markets, that entire conversation, right? Which has been happening a lot, right?
Yeah.
And SAMI sits at that intersection. The data informing decisions and then the community angle of it. And so maybe before we get into the nitty-gritties, I think we should probably give us a masterclass on like the basics of what drives this conversation. Where did it start? Why are carbon credits a conversation we are now having when it comes to climate mitigation? I feel like I know it feels like a primary school class, but just jog our memories on why are we here? Why carbon credits and the linkage to climate change? Yeah.
Okay. So initially, maybe if I take it back, during my high school, we used to talk a lot about infrared radiation, the greenhouse gases, and the need to mitigate the effects of climate change and the accumulated heat that is global warming. And carbon dioxide being one of the greenhouse gases, it traps a lot of heat within the atmosphere. Therefore, an adverse effects on the existing ecosystems. So there's need to change. But this kind of interest came to die down as I began my career in GIS and remote sensing. So during my final year, we used to we came across applications to remote sensing. And there are some articles which are talking about carbon sequestration, carbon stock, and how to quantify the same. So I wasn't really interested in the same until I came across a student from Dedan Kimathi who was doing her master's. And she was doing a project on terrestrial carbon within West Pokot County. So she just highlighted to me about the topic and if I'll be interested to join as an assistant. So at first I used to dismiss the topic a lot, but I had to go and look a lot inside and try to understand how carbon stock and carbon sequestration is coming in. Now, so I just went ahead to go through her proposal, related articles she has done on the same, and came to understand it's quite a complex topic that needs also major input from GIS. So carbon sequestration, how do you understand carbon sequestration? So it's just the flow of carbon from the atmosphere, maybe into the soils, into the plants and into the soil. Back then, we used to learn something about photosynthesis. And you understand that plants normally utilize carbon dioxide to create simple sugars and then to complex sugars, which are stored as starch within the plant structure. Now, carbon sequestration, the process by which we convert the same air from the atmosphere into the plant. So we are technically reducing the quantity that is dissolved or suspended in the atmosphere and storing it into the plants. And when the plants die down, they store the same within the soil. And also there was this, I'm just bringing it from also an agricultural point of view. We used to learn something about minimum tillage. So minimum tillage was aimed at reducing the disturbance to soil and also exposure to elements. Exposure to elements means that there'll be volatilization or decomposition of stored carbon within the soil or exposed soil into the atmosphere. So you are increasing emissions. And according to IPCC and RED+, so RED+ is just the reduction of emissions on deforestation, on degradation, deforestation and forest degradation.
Yeah.
That is RED+. And then there's also IPCC guidelines which outlines how to arrive at some of the quantification methods. Now, I went through all those researches for me to understand the topic, and then we achieved something at the end of her research. I think it is almost coming to an end currently. Yeah.
Okay, I think you have explained carbon sequestration quite well. I'm curious to know, we talk about it more on the climate aspect, but I've heard you mention the agricultural aspect. Can you marry the two concepts?
Okay. So here we have like two aspects. We have MRV, which is measurement, reporting, and verification.
Okay.
That is method 1. Method 2 is there's agriculture, forestry, and other land uses. So we have a set of organizations. One of them is Vera. So that one only assigns you tasks to give proxies to quantifying carbon. So you report on measurements. So you might say, for example, you are doing a permanent sampling plots or doing a measurement on the tree height to get the canopy structure. Maybe you are measuring on the altitude or the elevation, so you are reporting on the elevation, the tree species. So you're just doing an inventory on forests, so such that they can feed into the systems and calculate or quantify the carbon sequestration.
Okay.
And then the second method is this agriculture, AFOLU or something. That is agriculture, forestry, and other land uses. You can quantify emission from agriculture. And most of the companies normally say you minimize disturbance to soil. So you might apply herbicides to minimize soil tillage or land tillage.
Yeah.
Okay.
Yes. So they normally encourage like farmers on conservation measures more than measures that tend to disrupt the soil structure or the plant structure in your existing land. So that is agriculture. So you can quantify carbon from agricultural perspective, and also from the forest perspective. Yeah.
I like that. So meaning what I'm getting from this conversation is the entirety or the goal of what we are all doing is finding ways to quantify carbon stock from
and
all
then
these elements.
From that now initiative, we are now trying to get ways to reduce emissions. Yes, so while we quantify the carbon, we determine whether it is a carbon sink or not.
Okay.
Therefore, we can give recommendations appropriately.
Yeah. I see. You get what?
So the whole point of carbon sequestration or the quantification of carbon is to look for ways to mitigate, like.
Yes, and what comes into your mind when someone is recommended on more greener ways of maybe doing agriculture and using energy? We are striving towards climate change mitigation measures.
Okay.
Yes.
Yeah.
Okay.
Oh, that is so interesting. So this whole conversation is just purely on let's minimize the emission, but also how do we quantify the stock, the carbon stock that's in.
So that we are able to minimize it.
Yeah.
And where are emissions coming from?
Okay.
I see. All right. So now that we have that in mind, so you have this proposal, you've looked at it, and you've seen, the complexity. Okay, from my angle, the complexities that come with it.
So, and it is one of my fears. So I have to face it.
Yeah.
So out of that fear, it really propelled me to go deeper and try to understand it.
Yeah.
Yes.
And so now that brings in what I'm calling it the hidden layer, for lack of a better word. And hidden because I think when you're having mainstream conversations around carbon credits, there's rarely there's rarely a touch on the data aspect of it. And I
Yes.
think that's really important because that's what powers the preciseness of the decisions you're making. The way you're saying, is this a carbon sink or not?
Yes.
Right? And so I'm curious to know, from your perspective, as you're going through this research and you're looking at it, what are the immediate observations you're seeing GIS and remote sensing can answer just by looking at the problem statement she's trying to address,
Yes.
and how you see your angle as a practicing GIS analyst coming into that research? What are the key questions that come to mind immediately when you look at it that, oh yes, GIS can definitely answer A, B, C, D? What does that look like?
Okay. Before I move to that, there is an input I've forgotten maybe to mention. There is something on emissions and the industries.
Okay.
Right.
So industries normally tend to pay the carbon tax, or they buy credits. Say, for example, one credit is a ton of carbon dioxide emission. So they buy the credit. So this revenue that is realized during this transaction, that is the revenue that is going into these companies that are doing proposals on trying to encourage a forestation program to fight against forest degradation. It is going through that.
Okay, wait, can I cut you short a little bit? Can you first explain? Okay, we've understood the carbon sequestration part. Explain carbon credits before you get into
Oh,
them.
okay.
Yeah, just
Yeah.
explain carbon credits or how
Okay,
they
so
work.
for carbon credit,
Yeah.
a company normally emits several tons, might be thousands of tons of carbon
Yeah.
into the atmosphere. But who is responsible for taking this carbon from the atmosphere? It is maybe the farmer or the landowners or these organizations who are encouraging restoration programs and stuff.
Yeah.
Okay.
So while they buy the credits on the carbon markets, they normally, so the revenue that is realized is normally maybe used to do leasehold, and then a part of the revenue that is realized during this process, it can be shared at a certain percentage with a farmer. Say, for example, you are paid land rent, and then you are liable to get a certain percentage of the carbon credit that company will get. Say, for example, it gets like $1 million per year. So a good contract will highlight you with the figures. Say, for example, you get 20% of the credit and then a certain percent of the land rent, because these projects tend to take long. They might take almost 40 years because trees take long to grow. So they'll give you like a certain percentage of the credit and then at the lease, because initially you used to depend on the land, maybe for grazing
Yeah.
or farming. So once this land now is sorted mostly for the carbon credit activities or the afforestation programs, you are given that kind of amount of money for you to be able to do some other activities for you to maybe to compensate for what you don't have currently. So the credit itself, the industries releases the emissions into the atmosphere. So you, as the farmer who has planted the trees, you are trying to ingest the
Yeah,
released
the
carbon
carbon,
dioxide from
Yeah,
the
from the
atmosphere.
industry.
from the atmosphere.
Yeah, okay.
So that's how the carbon credit works. So the land acts as a factory
For the gases.
for the gases,
Yeah.
because land itself has value. So it acts as a factory or an industry to ingest carbon dioxide. Yeah. So now, for the technical aspect, now that is quantification, data, baseline monitoring or data collection, and the inventory keeping, and also informing now the farmers or the stakeholders. That is your role as a GIS data analyst. You want to keep an inventory of all the farms in Kenya.
Okay.
Those that have fully been paid, maybe those that need to be transplanted, those that need to be maybe tilled before we plant, where are those farms, you as a GIS analyst have to keep an inventory of that information.
And maybe if I'm a farmer listening to this and I would want to get into the carbon credits aspect, how do I go about it? Maybe I have acres and I would want to also
lease it or something.
like give it out.
Okay, so you just go into what can I say? There are very many companies doing the same. So you do a background check.
Okay.
And also, while doing background check, you might find one or two people who are currently in that kind of organization, and then you try to check out the contract they're having with the organizations. There are some organizations which normally tend to give you they rely on promises and say, at the end of the year, we'll get, like, they don't mention the amount, but they'll get money, and then they'll be paying you. They have not quoted the actual amount or the actual figures. That's a red flag.
Okay.
So a company that offers a contract with the defined figures, clear exit, entry and exit policies, very clear, and the policies that you can manage personally, and have been exposed onto them, and understand how they mean. Like, you might get that you signed off your land without really knowing.
Yeah.
Okay.
Yeah. So a company that offers a clear and straightforward contract is the suitable company you should sort and go into.
Thank you for that.
Yeah. I want to go back to the initial question, and I like that you've mentioned some of the role of GIS analysts within this conversation, right?
Yes.
But I don't know if you can put it into more words from a holistic perspective on, as you're doing this project, and then tying it very closely with a practical scenario or a on-ground experience you've had on the use of GIS in better understanding carbon stock, carbon sequestration. What does that look like from a high-level perspective? Someone who's wondering, is GIS a technology I should go for when I'm trying to understand this carbon? Is this a carbon sink or not? The questions you were saying, right? From a high-level perspective, what are those questions that it answers just from the jump of it that makes it a really unique technology to go for when addressing or trying to get precise answers around this carbon credits conversation?
Okay, so generally, in GIS, we are normally given two kinds of data sets.
Yeah.
We have the proprietary and the open source.
Yeah.
And most of the companies at the scoping stage, they normally start with open source, low-cost Earth observation data before moving to the expensive proprietary sources.
Yeah.
So they normally do like this. You'll get baseline data as open source, mentioned from the satellite images, which can be used to do the indices, do the land use classification, do the mapping of the farms entirely from existing data sets. And then, once you want to improve now, the accuracy of the measurements.
Yeah.
You now go to proprietary sources. And can I give examples?
Yeah.
Feel free.
Okay, so for open sources, you might tend to go for mostly Sentinel datasets. So you want to quantify the forest cover in terms of volume and area.
Right.
So by doing a rough approximation, you can just do classification of the biomes or the classes. You get the forest, or you mask out other classes and remain with forest.
Yeah.
You've quantified the forest in terms of, you also do validation. You've already quantified now the forest in terms of area.
Yeah.
But you've not quantified it in terms of volume.
So by volume, you mean the volume
By
it's
volume
absorbing,
is biomass.
the CO2, the biomass. Okay.
Yes. So you've not quantified it in terms of volume. So for volume, you go to datasets that give you the structural metrics. Structural metrics can be diameter, breast height, canopy structure.
Oh, right.
Yes.
So the properties of that tree.
Yes, the properties of that tree
So
in
the
3D.
Yeah, in 3D. So the
Yeah.
diameter. Okay.
Yeah, so you get the diameter at breast height and get the height of the tree or the crown size. That is the canopy size. And some of the data that I've interacted with is we have GIS LiDAR that normally gives you the structural matrix. Another one is the Sentinel one. Mostly they normally give you elevation that is the DSM, digital surface model, and the digital elevation model, and then the height, the canopy height. How do you normally get the canopy height from your undergraduate?
Yeah, I want you people who GIS specialists to answer that one.
I think if you've not gone deeper into the
So
the
it is
carbon stock
you normally
estimation,
take
you want to be able to tell.
the whole elevation. Is it digital surface model?
Yeah.
Or and then you subtract. That is like all elevation means from mean sea level to
All the way to
height of the canopy. Then you subtract the bare elevation. Bare elevation is from mean sea level to the surface where you are.
Yeah.
So you subtract the bare elevation, you remain with the canopy. So the canopy is you have the height of the feature from the surface
Yeah.
to the crown. So that is how you get the structural matrix of the tree from the Sentinel-1. So Sentinel-1 is also very crucial in quantifying the 3D matrix of the trees or the forest. Now from here, you will be able to calculate the volume or the biomass of that particular forest by use of allometric equations as guided by the IPCC. So IPCC is just intergovernmental panel on climate change. Yeah, so it gives a guideline on some of the equations that are used to quantify biomass. And I think I've interacted with Chef et al.'s equation on biomass calculation. Now from the biomass, you'll be able to quantify
The volume.
the carbon dioxide that is sequestered or the carbon that is sequestered.
Okay.
Because you start from biomass and then you move to the carbon that is sequestered.
Okay, and having mentioned all these images and the volumes and the calculations, which tools or softwares are you using to do this?
Okay, so there's no one constant software that you're supposed to use.
Yeah.
Maybe you might put to practice the Copernicus Data Cube, and you might also run Jupyter Lab on Copernicus Data Cube. And then another one is the Google Earth Engine, that is the JavaScript, and the Python API. So for the Python API, you might need to run a service account such that you don't need to authenticate each and every time you want to maybe to access and acquire dataset from Google Earth Engine. So you just run the JSON key file, then extract data from the Google Earth Engine into your pipeline.
So as a GIS data analyst, do you go with what the client is asking for? Because maybe a client would say, I want it in JavaScript or I want it in Python. Or do they give you autonomy of do whatever works for you, but these are the results we want?
Okay, so they are normally strict with the results
Okay.
and the visualizations.
Okay.
So maybe they want like, the ranges of the carbon, maybe it is between 10 to 50 tons per acre in a certain space you are quantifying. So if you are getting strange values, they also question your methods.
Okay.
Where are they coming from? So you have to be strict with the results. But for the methods, they normally highlight a range of methods, and then from the range of methods, but they normally also encourage the open source methods. So you'll hear them mentioning like use QGIS, use Excel, use Python, use the course Google Earth Engine, which is open source. So
Yeah.
they'll encourage mostly use open source methods. And then also there are some other companies, they normally have their own custom-made software that you use to conduct now the MRV, that is the measurement, reporting, and verification.
Okay.
Yeah.
I like that you've broken it down really well on the data sets, the software options that people can use. I'm curious to know, as you're doing this research, are there bits where you had to pause and be like, I don't think Earth observation or the data sets you're using are ready to answer some of the questions I have? Are there barriers that we still... are there limitations that you came across with the data sets that are currently available within the Earth observation space or the GIS space that you think would have made work very easy? Are there barriers you came across?
So at first I intended to do enhanced land use land cover classification by use of the ASTER. But I don't know what normally happens when you download ASTER into your maybe pipeline. The images are normally degraded.
Okay.
I don't know why, but as when you are into their platform, the images look quite fine. But when you download, they look degraded. So
And it's not a storage issue.
Yes, it's not storage issue. So I couldn't quite solve that. So I had to stick to a Sentinel dataset. And then went on to do fieldwork validation.
So it comes back to the resolution of the data set, which is still something.
Data set,
And especially if you're working at a low cost project or something, then Earth observation can be really expensive. Satellite data can be so expensive. Like that is very, maybe if you've worked with ASTER data before, that's something you can chip into. Have you tried using it? Have you experienced the same limitation? Did you find a workaround? That would be interesting to hear from the community as well. I'm trying to think of what this looks like from a community level angle, right? So you've done we've done the analysis, we've managed to quantify it on this is what's being stored. But like, we rarely talk about what the impact looks like at a granular level. I don't know if you've experienced that or interacted with that at community level, where you're able to tell, these are the benefits I see that have come to this community. And if you have, how does impact show up in communities at a granular level for carbon projects, especially now after you've done the analysis, right? And you've served the results. So I'm assuming the next step is impact or rollout.
Yes,
I don't know, are there
I
phases?
think rollout. So impact is never felt on the go. Maybe on existing forest cover.
Okay.
So if they determine that an area is forest cover, but it is not a carbon sink. What do you mean by a carbon sink? A carbon sink is just a system that is absorbing more carbon than it is releasing. So that is a carbon sink. It might be a wetland or a terrestrial forest. Now, if they determine that it is not a carbon sink, they'll need to encourage maybe replanting, reforestation, where there's extensive deforestation for the cases like Karura and other forests that have been notoriously been deforested over the recent past. So they'll determine if it is community forest, they'll tend to do the value, the current value or the current carbon value of the forest. Now from it, they'll determine how will this community benefit with alternative activities that will now tend to check on how the rate at which this forest is being degraded. So say, for example, they introduce something like beekeeping or apiary, while also transplanting or reforestating some of the sections of the forest. So maybe the community normally benefit in terms of alternative economic activities, which are supported by some of these companies.
All right.
Yes.
Oh, so it means if we've come to your community, we've realized the forest land that you have is not storing enough, enough. From the quantification we've done with our data sets.
Yes.
So now what you want to do is how do we make the community benefit from this project, right? So we are now recommending that maybe if you're doing charcoal burning, you should do beekeeping as an alternative to ensure that you're really able to hone in on storing this carbon so you can get more value from what you're doing.
Yes. So like looking at maybe it is from the arid areas. So they normally do like this. They'll do like well drilling. Such that the community has access to water. and then they reduce that kind of hardship the community is having while utilizing the land for other activities. Because there in the arid areas, the lands are extensive and they're not put to proper use. So they normally do like suitability analysis or determination of ecological zone or agroecological zone, and then plant suitable species that are also drought resistant in those subdivided agroecological zoning.
So now it feels like I'm seeing the uses of like Earth observation and GIS data cut across the different phases. Because now you're also talking about even the identification of the zones.
The zoning,
And then there's the monitoring, but there's also the quantification of this carbon.
Yes.
It feels like it cuts across the different primary, for lack of a better word, phases that cut across this carbon markets ecosystem. Is there something that surprised you the most when you're working in this space? That you came across and you're just like, I had not thought of this, or I not from a holistic perspective, whether it's data, whether it's the project or the community or the research angle of it.
So I think something that surprised me a lot is I think people normally misquote this topic for carbon credit and stuff. Because initially I used to see like they're coming to utilize the land to do some other maybe hidden agendas, like they're doing mineral exploration and stuff, until I dove into it and it was a whole different thing. Like, oh, it's not like that. Oh, okay. It was a bit surprising to me.
Conspiracy theorists almost took you out with that one. So going back to the impact, so meaning monetarily, the community is also able to benefit from it, either long-term or
long-term or short-term activities.
Okay. And sorry, Joy.
Oh, I wanted to ask, because the major concept of the carbon sequestration you said is the climate mitigation. Would you say that it is actively working, or we need to give it time?
I think we need to give it time, because there's also a rush that it is not working, but this is something that we'll realize in about 50 years. So it is something that we need to, it's an industry that is still growing. It's how many years old that I've heard of this?
10. Me, I started hearing of it
It's
in
very
20.
recent.
For me, it is less than 5 years.
Less
than 5 years. So it is an industry that we need to give it time.
Okay.
And also, it is projected to be of great significance in the future.
Okay, so this is where we put blind faith.
Me, I've had 50 years. I was like,
50.
But I like that you mentioned it's a long term. It feels like it's a long term investment that you put in and wait for your returns quietly. There's something else you mentioned offline, and you talked about the same angle of carbon credits, but you working on it from a mangroves ecosystem, right?
Yes.
And I'm wondering how, because now with mangroves, I feel like that changes even how you do the quantification, right?
Yes.
And how you even do the analysis and you call it volumetric analysis,
right? Volumetric.
On understanding the storage of it. So for anyone who's getting into the projects like that, and they're looking at it from a coastal perspective, how different was that compared to when you did it in Lodwar? Was it Lodwar?
In West Pokot.
In West Pokot. How different is it when you're approaching it from a coastal perspective? Just from a very high level, without getting into the technicalities, how different is it when you're doing that same carbon credits conversation and quantification, but from a mangrove ecosystem thingy, right? Because mangroves are so different. It's not like kawaida trees.
In simple English.
The terrestrial.
And in simple English.
Now, for the one that I did in West Pokot, you find that the trees are tall, so maneuvering the terrain is rough.
The
trees are tall and aging, the crown size is large. So you tend to use methods that are to suit that kind of specification.
Yeah.
Now, when moving to coastal areas, so I expected also to find the same
thing.
The same thing. But upon reaching there, that I'm now realizing that you're supposed to focus a lot on the routing system rather than the height
canopy,
at the canopy.
Yeah.
Because also looking at the canopy, they are not very tall, like somewhere like 10 meters, not 10 meters, 10 meters is way too tall. I'll use like around 6.
Yeah.
Around 6. So that's not too tall, like the one that I found overland in West Pokot.
Yeah.
So the methods entirely changes. And also, looking at the coastal areas, we are dealing with the wetland, which is marshy. So we are also focusing on the salinity and the hydrogeological aspect. Yes. So the all methods of determination of some of these metrics to quantify the biomass and the carbon stored in order to determine the rate at which we need to restore the coastal areas was quite different from what I did in West Pokot, that is for terrestrial carbon.
So for the mangroves, for example, for the height, let's say, are you going to measure it from the surface of the water, from the...
Oh yeah, to know
from the bottom,
Okay, so I think what we did was by use of a pool finder.
What's that?
It's just an instrument that is used by the well drillers to determine surface water level, and the underground water table.
Okay.
So by determining the underground and the surface water table, we are able to approximate the depth at which the routing system has gone.
Right.
That's clearly very
now,
different.
The routing from the routing system, you'll be able to now quantify from the height. You'll be able to quantify the biomass of the roots. So it will be the biomass of the roots plus the biomass that is found above that is AGB.
Surface.
So it is BGB and AGB. So BGB is the below ground biomass and AGB is the above ground biomass. So we had also the metric that used to determine the above ground biomass, which is the crown size and the height.
Yeah.
Yes.
Okay. That's quite different. Was it a challenge for you?
At first it was a challenge.
Yeah.
It was a challenge in determination of the real depths. Being able to determine, looking at the pool finder, it is able to measure mostly at a depth from around 10 meters. So you find some sections, it is just giving you readings like it is fully water from all the way from the surface, going deep inside
down,
into the underground surface. So like at first I didn't know how to maybe amplify some of the graphs, do the correct measurements. But after the first reading, now moving into a second permanent plot sample, I was now able to fully understand how the hydrogeological structure of within that area was looking like. Because also when doing a hydrogeological survey, you also need to sample the levels that you get with the well catalog data of the adjacent areas or
There's a
regions.
well catalog.
Yeah.
Wow. This is a very technical.
I think it's safe to say you learned as well.
Did you
Yes.
learn? It feels like you know.
Before that, I
Yeah.
think I'd done training on the same, on water detection and
Right.
at Measurement Systems Limited.
Oh, okay.
Oh,
I'd
so
done
they
the same.
teach you all
So
this.
I had known most of the maneuvers in and around. And then also, before maybe we began, I failed to introduce maybe something on initially having that passion in geography just before I joined campus. So you are able to connect some of the concepts when you get certain signals on some of the graphs or the water levels. You are able to understand Is this one a volcanic ash? Is it a sedimentary whatever?
Yeah.
You're able to understand as you transition from one resistivity to another. Yeah.
And yeah, that's very insightful. And I like that you mentioned even some of the training you undertook. For anyone who would be interested, I think I'll add the link. Do they still offer trainings? You called it measurement
Measurement systems limited.
limited.
I think they normally post openings. I think.
Yeah.
Even I think I came across it at the WhatsApp group that we normally have for GIS and RS coding.
Yeah.
So that's where I came across it. But if you go into their website, I think you'll be able to get those advertisements they normally make. Like, we are now doing training for the next cohort for the interns. So I did like an internship kind of program, but it was around 2 months, approximately 2 months long. But I was able to get exposed on most complex these measurement tools that we normally use from the survey, from the normal real property survey to roads, and then to hydrology.
Okay.
And to roll back on that, or have you explained that further? Because now, from what I'm hearing is, you clearly took this direction, and it's something you've decided you're getting into and you're going to stay into, based on even the experience you've done and then the training.
Yeah.
And so I'm curious, for guys who are trying to figure out, is this a career path that is worth exploring, especially now the carbon markets and what you're talking about, measurement systems? Is this something that you see staying within the industry long term? And is this especially for people in campus who are trying to figure out, do I want to get into this? Or even guys in the job market who are just getting in,
for
right?
Sure. Yeah.
This carbon ecosystem and the need for geotech right? Is it, I think you call it, is it a hype?
Yeah, is it a hype
Or is it a long-term thing where we should try and learn and get into it for people who are trying to figure that out? What are your thoughts on that?
I think to some people, it is a hype.
What about you?
To some people, it is an interesting topic that needs to be explored deeply on.
Okay, let me rephrase the question. Because you've been in it for now,
Yes.
would you say it is something that is going to die down, or is it something that is going to continuously grow and people who are interested in can also actively join?
Okay, so according to the current prospects, the industry is projected to grow. And for anyone who is interested or truly interested, you should venture in.
Right.
I will encourage you venturing in.
Okay.
Yeah.
And then I think the other one that you mentioned also offline, I'm curious to know what you're currently excited about from an industry, either tech or research perspective, that you're really looking forward to getting into or exploring within the same carbon conversation, right? Are there measurement systems you'd probably want to improve on or work on? Are there use of AI, for example, is something you'd want to explore? Yeah, what does the excitement channel or pipeline look like for what you're currently doing? Is there anything you're really excited about?
Okay, so currently most of the methods for these estimations are fragmented.
Right.
So I always visualize that one as a gap that needs to be filled. Like, an accomplished system needs to be put in place for it to automate the data pipeline, the carbon estimation, depending on the method that you want to estimate the carbon.
Yeah.
Because you might find someone needs to estimate the carbon for the grasslands, carbon for the wooded areas. From the coastal areas. Someone also wants to estimate carbon from the submerged plants, that is seaweed, seagrass. So someone wants to estimate carbon from that. So there should be a system for each ecosystem. Be it the terrestrial, be it the water, the marine. Yeah. So there need to be that system to automate from data extraction to data cleaning, or doing the data quality check. Validation metrics should be there, and then moving all the way to now informing the stakeholders. Because if you get a certain, for example, how you communicate the information or the results of your research matters a lot.
Yeah.
You have quantified the carbon, and also I've mentioned something on the carbon sink. You have quantified your carbon. So to stakeholders, you need to tell them, is this a carbon sink or not?
Yeah.
Or now, what interventions do we need? So you need to suggest the interventions. Are they going to reforestate? Now, if they are going to reforestate, what species are most suitable here? Is it deciduous softwoods or deciduous hardwoods? So you need to also determine that. That is suitability analysis in action from now GIS and remote sensing.
Okay, that's interesting because there's a what is it called? A project that I wanted to do on vegetation and carbon stock estimation. I think I'll see you after this.
Yeah.
Okay.
Even for someone who wants to get into me when you're talking about that, I was just like, that also feels like a very good entrepreneurial path to take.
Yeah.
Because that's a whole system we've talked about that does not exist.
Yeah.
Fragmentation and how you bring
They're
everything
just
together.
fragmented because
Yeah.
you get there are several organizations, they just have their own methods. Or even others, they normally contract
People from
outside to do the baseline monitoring, verification, and then quantification.
Yeah.
Okay.
They normally contract other firms to do for them. Now, if you had that system in place, so you just need to plug in the study area, do the data pipelining,
And it's set.
And
quality
that's
check,
it.
and then you have the quantity of the carbon.
Okay. And now that Yariwo, you've mentioned the entrepreneurial aspect. Let's be real, guys. At the end of the day, the money matters. In this Singapore economy, money really matters. Do you think it is worth the money to get into carbon and as a GIS analyst?
Yeah, I might say can I maybe give rough approximations?
Yes,
The
please.
better.
Yes,
That's what we need.
by all means.
Okay, so I'll say that according to Kenyan markets, at an entry level as a technical GIS analyst, data
Yes.
analyst,
Yes.
it might range between 80,000, that is per month, 80,000 to about 180,000. And then for an intermediate or someone who has a bit of experience, it might range now. That is now from GIS data analyst.
Yes.
Now from a remote sensing and MRV
Yes.
analyst. That is a monitoring or measuring, reporting and verification. So you have knowledge on monitoring, verification and reporting.
Yeah.
So your salary might range between 150,000 to about 350 to about 350,000. Now given now the farmer also, I mentioned about the farmer.
Yeah.
Now for the farmer, you might get that the farmer has a contract for the carbon credit portion and then for the leasing.
Okay.
Right.
So you might get that the land that you used only to graze, it is giving you twice as much the revenue you used to get in a single year. Yes.
Are you going to put your money there?
Put your money where your mouth is.
I really like how you've painted that picture for us. Sorry,
Yeah,
guys.
I think that one is you've done it well. You've been precise enough. I think I'll look into it personally. I don't know if you're looking to get into it in the comments. We can do a startup and then get this.
Yeah,
credit money.
me, I'm very interested in that fragmentation thing.
Or if you are a farmer and you have acres, contact me. Contact me, nitakuonyesha.
Before we end, Samuel, you're clearly very well versed with how the carbon markets work from a data perspective, right? And how to help people come up with precise solutions from what you've mentioned, monitoring, reporting, what was the other one?
On the
And verification, as well as the steps before that. So can people get in touch? How do people get in touch? If someone wants to get in touch maybe for
project
Projects
Or
execution.
even a job.
entrepreneurs,
Or
jobs,
Yeah.
is that something you're open to, even for supporting researchers, right? For guys who'd want a geospatial angle or an eye to look at their research, how do guys get in touch with you? Is that something you do?
So currently I've not really created So I normally use my personal email
Right.
and telephone.
Okay.
So maybe can I say it?
That's sensitive.
That
Can we share
maybe
your
the
LinkedIn? Are you active on LinkedIn?
Yeah, the
Yeah,
LinkedIn
you
profile.
can just do Ambuka Sami.
Oh,
on
Ambuka
LinkedIn.
Sami. So
Yeah.
say someone can just send you a DM and you'll be able to
yes,
see it.
I'll be able to answer it.
Okay.
Yeah.
So we'll also include Sami's LinkedIn page profile
Yeah.
within this episode description.
Because some of the things I've been able to post there, but I've done quite a number of projects that I
You have
haven't
not yet
posted there,
posted.
but I'll soon create a portfolio and share on my LinkedIn.
Yeah.
Yeah.
So follow him on LinkedIn.
Yeah. That was really insightful. Thanks, Samuel. For the audience who are listening, well, from my perspective, I've had a really good understanding, especially because I was always curious on this carbon conversation that everyone is talking about. What is it? Can we demystify it? And thanks, Samuel, for really demystifying it for us. And for geotechies, right? Him breaking down the methodologies, the data sets,
The tools,
the
money,
the career path. That was really insightful. So yeah, let us know in the comment section if you are in that same ecosystem, or if you want to get into that ecosystem, what tools are you using? Get in touch with Samuel for any questions you might have. But besides that, I hope the episode was useful to you. Please remember to subscribe, and let us know in the comment section what you thought of this episode. Thanks, Samuel, for coming to today's episode. I hope you had fun. Was it a high pressure environment?
No, it was quite a casual conversation.
Yeah, you had a lot of knowledge. Thank you for that.
Yeah, thank you. So yeah, that's on today's episode of the pod. Thank you so much. I think that's it. Until next time.
Bye.
Bye. This is the GeoHabari podcast.